here, I guess. All right, so let's go back to the stuff from class 2, and we're going to do this simple CSV example. We'll start with that. I probably already have it saved somewhere, but this is the one that CSV, again, that's comma separated value, so it's kind of a text file that has data in it, and all the data elements are separated by commas. So that's the comma separated value. There's no other specifications other than it doesn't have a lot of formatting or anything like that. It's basically a text file. So let's copy all of this thing, and let's get our Thani. I don't know what I typed. There it is. All right. And you probably already have this thing somewhere, but we'll start from scratch. In fact, no, that's a plot one, so we don't need that. Let's do a new and put this thing in there. All right, and let's just go through what all it does. Actually, let's save it. And I have a 382 folder. We'll do this. Yeah, I already have it saved there, but let's CSV example. Save it as that. All right, so looking at it in the editor, most of it's grayed out, right? It's just commented out, so it's either a comment. Some of these are functions and commands that have been grayed out just to save them for later, basically. So there's not a actual, if you took away all the comments, there's not a whole lot of code here, but let's see what happens here. So this very first line, this is the first thing that would happen, and it's just going to assign this F to, well, all of this stuff to F, the variable F. So this is a file. This is the file that we need to generate. College football school standings 2018. The name only has to be this because that's what we chose it to be. We could put any name in here that we wanted. Basically, we're going to go find a file, and the Python code is going to also look for that file. Now, we haven't done anything about telling it where to look for the file. So by default, it's going to look in the same folder that we wrote this code in. So we need to put this file in the same folder, which it probably is, but let's check. Let's get a bunch of stuff out of the way. So I put that in. I have a 382 folder. Inside that folder, I have in class, and there it is right there. So we generated this file by going to the website that was listed here. So it actually gives us in the comments. Kind of hard to see on that screen. I don't know if we can make that better or worse. We can make it worse for sure. I don't know if we can make it better. Oh, kind of. It's very sensitive. Oh, all right, don't move. All right, there we go. So right in here, there is a website. So let's go there. There. Let's. Oh, all right. Classes. Go there. And here's all that data. And I guess we could choose whatever year. I assume, yeah, we can go back to different years if we wanted to, and different sets of data, or whatever. We just have this set of data. But if we tried copying this and pasting it to create a CSV file, we would get a lot of stuff that is not just the data. We get these headings, we'd get table information, and all kinds of stuff that the little parser that we're going to use would not know how to separate all these things appropriately. So this particular one has the option to get table as CSV. It even says for Excel, although we're not going to put it in Excel. So now, I think here's where I went wrong last time. I think I probably did something like this, and you can see the little bit of extra data that it doesn't know what to do with. So let's get, I actually don't even know if I want all of this header, but why don't we start at 1 and get that, because I don't know if we want all the labels for stuff. We just want the actual data. Let's get that. And then again, you don't want to go get extra stuff down here. We want to end right there. So we'll copy that, and then, well, actually, then we need to put that into something. I'm going to use Notepad. Actually, on this computer, I have Notepad and Notepad++. this Notepad++ is actually a pretty nice little editor for code. We're just going to use regular old Notepad though, because we're not editing code. We just want to generate our data file here. So this is the thing. And then we need to save it, file, save as, and then we have to save it as a specific name. In fact, why don't we just, let's see, this was college. Sometimes spaces create problems, sometimes they don't. Football data 2018. All right, so and .csv, so we want it to be a comma separated value. And this save as type, there's probably not, yeah, there's not a CSV option on the save as here, so I'm going to encode the little tag right here. Just tell it that that's what I want it to be. Now, what I did though is I put in my own name, college football data 2018.csv. So this will not work. Oh, you know what? I don't know where I saved it. So where did I save it? Oh, I actually did save it in the right folder, so by accident. So be sure you actually put this data in the same folder or location that you put the code that wants to access this data. So what I was going to say is that I named this my own thing. This is looking for CFP school standings 2018.csv. So it will not find the file I just created unless I go in here and college football, I think I said data 2018. I'm not 100% sure if this particular part is case sensitive or not, the file name. Other parts are case sensitive. I don't know if the file name is or not. So I did use the same capitalization that I think I used on the other one though. So this little line, I've got the data file in the same folder as this, what I called CSV example.py. Also notice anytime I'm up at the tab, look at the tab up there, CSV example.py, asterisk, anytime there's an asterisk by it, it means that you haven't saved the current edit. So it has edits that haven't been saved. So if I hit save, that asterisk will go away saying that, hey, I've got everything up to date in the file system. This particular editor, I don't think, has a way to automatically save on, periodically or whatever. Some might, but I don't think this one does. So that's just, and it'll save it whenever you run it though. So if you run it, it'll also save it. It is a good idea to save your code often, and it's also a good idea to save different versions of your code even. So you have a working version that all the little functions that you've written work, and then you save that, and then you add some new stuff. Save the new stuff as a slightly like version 1 or version 2 or whatever, so that you can always go back to a previous one that hasn't been modified with whatever you've been hacking on it with. So generally good idea to have multiple versions of your stuff you're writing. All right, so here it goes in and it takes that, it's read in that file and it put it into this variable called F. And then this is going to take that variable F and split it by rows. So this /n is the new line character. So like it's hitting enter on the keyboard. So every time it sees one of those things, it's going to say, hey, that's the end of a line. It's going to split all this data into rows basically. So it's going to start making it look like the data over here, but in a list. Well, technically, I guess it's not a list yet. It's in this thing called rows. Here, we're about to make a list of it. So notice the difference here. F equals, and it's just the file, and rows equals, and it's just this function that splits the file into rows. Here, I've got a little bit different symbol. I've got these brackets. So in Python, the brackets let you, you might know it better as like an array where it's going to have individual addressable elements in it. Right now it's empty, there's nothing in there, but the little brackets, the square brackets here mean that I want this variable to be a list or an array, if you want to call it that. It's going to call it a list here, but it'll let us go piece by piece and we can address any specific element in the list that's going to be called cells. So this doesn't do that. All this does is create a variable or a list named cells and makes it empty. So there's nothing in there right now. And then here for R in rows, this is, you know, in the Arduino language, there's for next and things like that. This is a similar type of controlled loop that has a specified endpoint, and this is the way you would write it in Python. So it looks, it still says for, it doesn't say next, and it doesn't really have a counter like I equals I plus 1, or it doesn't have anything like that. But what they're doing here is for R, which we already defined, actually, no, we haven't defined R. R is the variable that's going to get counted here. We've defined rows. So rows was the output of this line 13 that has all of that data, all of that split into rows. So for every row, basically, we're going to append, so add to the end of the data set to sales. Sales is empty right now, so we're just going to keep tacking on things to the end of sales, and we're going to split based on the comma. So every time it sees a comma, it's going to create a new element in sales and add that to the thing called sales, the list called sales. And so some of them will be empty. I noticed some where, you know, there's just commas back to back to back to back. So that is so that every row has the same size, basically. I don't know why some are empty, some are not. Oh, you know why? Because this last part of the sale is rankings, and some teams were never ranked. They didn't end the season ranked, they didn't start the season ranked, and they never attained a ranking anywhere along the season. So a lot of these teams just have blanks for that. All right. So this, oh, you know what? We will actually probably want to eliminate this because I already did. So what this is doing is, let's go back to our original data. I did not copy this part. Oh, my computer's slow right now. I didn't copy this. I manually said, hey, we don't need this because it's not really part of the data. It's just the headers. But this code right here assumes that there's some useless stuff at the beginning, and it pops it off. So the pop command here is just basically remove that line. In this case, 0, which would be the very first one. You start counting at 0. And so we actually did that. I did that on my end by just not highlighting these two lines. So we're going to comment these out, or else we'll actually end up losing Clemson's data and I think we might lose Syracuse also because it does it twice. So let's comment those out and see if that's okay. So those two lines are dependent on whether or not you actually copied these two lines over here, which I did not do. Yeah. Right, because sales, the way we set up sales is, yes, let me make sure. Yes, it should remove, basically, the first time we do it should remove this line, and the second time we should do it should remove that line. Well, so what happens is the first time you do it, 0 gets popped off and everything shifts over. So there's a new 0. So it will do it again to whatever's in the 0 spot. So everything moves over when you pop. So there's a whole lot more even that I don't even know about database management and all of these kind of things. But I do know that pop basically it's like you got a stack of data, in this case a list, and you pop off the thing on top. Yes, I think so normally I thought you could only pop off the top one, but it's saying 0, so maybe you can actually pop any particular line you want to. We could test that out and see, you put a different number in there and see if it removes that line. They shift up. Yeah, it fills back in. So there are different ways to do that where you just zero out might be a good word, but null out a line or a data set and not shift things around. But pop, I think, does actually reorder everything to fill in the gap. Top one again. Yep. These are more of the create empty lists variables. So points per game on offense, and it starts out empty. points per game on defense starts out empty. And then this points per game is actually the points per game margin. So it's the difference in the two is what it's going to be. So it could have been named better because it's not literally just points per game. It's the difference in how many points you scored on offense versus how many points you allowed on defense. So some teams will have negative PPG here because they allowed more points than they scored over the course of the year. And then this little here is a little bit more like what you've seen for the for next statement, but again, it says for every C in the variable sales. So C is this kind of like, and just a number that's going to be counted. It's like the counter that you might have used in the Arduino language. And it's going to say, take the points per game on offense variable and append, so add to the end of it, the float variable. So we are, in this case, specifying that it's a float. You don't always have to do that in Python, so I haven't tried it without specifying that, but this data set is mixed, right? I've got strings, words, and I've got numbers mixed in here, so maybe that's why you want to combine them together. I don't actually think Python would stumble if you didn't put the float in there, but I didn't try it, so we'll see. And then it says go to a specific one, so go to number 9. So if we look at our data set, you got 1. Let's see if I can make it bigger. All right, so 1 would be the number 1, 2, 3 is all of that, 4, 5, 6, 7, 8, 9, 1. Oh no, you know what I did wrong? I started with counting at 1. You start with 0, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 44.3 for Clemson. That seems real for last year because they kind of scored a lot of points. So it'll go over, and don't forget that no, we don't care about Clemson, but don't forget that you start counting at 0. On almost all of these things, you should count at 0. So 44.3 would be assigned to the end. So in this case, it's the very first number in this variable called points per game offense. And then the points per game defense would get added number 10, which is the next one down. So 13.1, they only allowed 13.1 while scoring 44.3. So those two get added. And then this is a calculation right here. So it doesn't go back and reference their data set. It says append, so add to the end of points per game, and then add this function. So the difference in those two. So points per game on offense minus points per game on defense. So this is kind of the margin. And then increment your I variable here because we're going to go through and do this for every C in sales. So every element, every row in the sales variable list. Yeah. This block 33 through 35. Yeah. That is defining them that they're list with nothing in them. Yep. And it doesn't say, so there are different types of ways you can define these things. This one is kind of the most generic way possible to say, hey, I want to have a list and I know nothing about it. So I just want to contain it in this variable. Other times you might want to create an array that has a specific numbers. Yeah, they're going to be 130 because I know there's 130 teams in this list. So there's going to be 130 rows in this list or whatever. And so there are some advantages and disadvantages to doing those things on the computational side. But this one is just generic. I want to have a list and I don't know anything other than I'm going to put stuff in this list. And then this set of lines actually goes about putting things in the list. And the way this for C in sales works is it says C doesn't actually mean anything. C could be any letter variable here that doesn't already mean something else. What is important is sales. So that for whatever in sales, and it goes through and it looks at sales and says, oh, there's 130 rows there. So, and it goes through every row basically. All right. So now we've populated these three lists with the points per game for offense, defense, and the points per game. But it doesn't. That's it. That's all we know is we don't know what team belongs to these things. We just know that they're parallel in that they match up. So the 0 element in each one of these refers to the same team, but we don't know who that team is. Why don't y'all take, well, first of all, let's run this and see if we have errors or if it'll do stuff. No, it works. All right. So it generates all this stuff right here, basically. It works. How about, oh, let me show you how it puts the output. It just prints. What it is printing, it is printing the entire list, points per game. That's all this stuff right here with just the numbers. And then it's going to print the max points per game, which is this very last number right here. So, and again, that's the margin, right? So that's Clemson, I assume. And see if you can take 5 minutes, and then I'll do it, of creating another parallel list that contains the team name, because we want to know what team did what. So see if you can take right in this area from 33 to 44 and make it populate a team list with team names. And then we'll do that.
6.5 hours later.
All right. So here's what I would do. If I wanted to create a list, I would call it team or team name. It doesn't matter. I mean, there's lots of ways to do this. I'm just going to say team. So I created a list. It's empty. I would use this same little loop here, and I would say to the end of team, append, and this is not a float, this is a name, so I would say string just to be careful with it, and then element number, I think it's 1, right? Okay. So 0 is the actual number that they've assigned here, which is just an order. It's not, I don't think it's a ranking number, it's just a number. And then index number 1 is the name. And then I've got the conference and a bunch of other stuff. So I just want the name. All right. So that should actually do it. When I run it, now it doesn't change my output at all, but when I run it, it should actually create the team names into this variable called team, or this list called team. If I want to see it, then I have to print it out. So print, let's just do all of them, team. So this will print all the teams, theoretically. Oh, I can. Right there. str is defined to be a string variable. So and again, let's just try not putting that in there, because normally Python doesn't care if you, oops, yeah, no, so it will care about that. It's not that good. Although they ought to make editors like, you probably meant this, and just fix it for you. But let's see if this works. Yeah, it worked fine. I did print team, print, and then since I didn't want it to literally print the word team, I didn't put team in quotation marks, and it print whatever the team variable contained. And I didn't put the str on here. I took that off because Python normally doesn't care about typecasting. It does it on its own. And it sees a bunch of words in there and it assigns them as strings. Yep. Float is a number with a decimal point in it. And so if I did float and it sees a bunch of team names, it will probably give me an error, I assume. Yeah, it says like, I don't know what number Clemson is. So it can't figure that out. So if I don't tell it at all what it is, what kind of variable, if a float or a string or a long or whatever, then it says, hey, that looks most like a string, and it just makes it into a string variable. And it's okay with that. But if I try to define it as something that it really doesn't look like, Python doesn't like that. So because Python is, I probably don't need the floats either. Let's see. Normally, you don't need to typecast in Python. Oh, but let's see. Oh, so the reason I have to specifically say that the points per game offense and defense are float variables is because this list that I've made is mixed. It has some things that are clearly words, like the names of the teams and the conferences they're in, and some things that are numbers, but numbers could be strings, or they could be numbers that you operate on. And in this case, I have to specifically tell it that these numbers are going to be float. And so I could make them integers, except if I make them integers, a lot of these numbers have decimals, right? 40.2, 44.3, and the decimals would get chopped off. So float means that it's going to have a decimal point in there. It doesn't say how many decimal points. It could be none, but it'll have something. So I do have to say that the points per game numbers are floating point numbers. Otherwise, it's going to default to them being strings, and it doesn't compute. So I did. I got all the names of the teams here. All right. So now let's see. Let's try. All right. So let's go here. What this is doing is this is well, let's see. I skipped one. All right. So I just use I, and sometimes N. Numbers or variables like that are often used as counters, and they're often reused in the same code. So in this case, I used I to count through here, I basically used it when I was doing the points margin. But then I want to reset it and use it for a different thing. So here it is being reset to 0. Here's a new variable. And this one's a little different. It says max value. So this is the maximum points per game. And it says, let's just start it out at something. Now in this particular example, it ends up also stopping here. But points per game element 0 is just the starting point. And max index equals 0 is just saying that, hey, we got to start somewhere. We'll start at 0, which is normally where you start. Index is the position of the variable, the specific element in the list. And then this little routine goes through and it tries to figure out which one is the maximum, in this case, points per game, which is point spread for the data set. And it goes through and it looks through all of them, assigning every time it finds a larger one. So if the current one you're looking at is bigger than what you currently have stored as the max value, then flip them out so that the new one is the max value. And it does that through every one of them and until it gets to the end. In this case, the very first one is the largest one, so it keeps that in there. And then it prints out the maximum score. It doesn't print out the maximum team, but right here, the 31.199. Now, I've got all these decimal points. Like, look at these. I don't know if yours came out this way or not, but it's kind of ridiculous. There are ways to format the output. See if I can get this right. To do that, and this is one of the things that's different in version 2 Python and version 3 Python. We're in version 3 unless you did something in the background to make Thani do one of the older versions. So I believe you do curly braces to say that I want something to appear here. And then, and I probably need it in quotes, even though it's not, it knows that I don't literally want to print curvy braces. It knows that I want to print a value in there. And then I do dot format. And then what do I want to put in there? I want to put the points per game in there. And then inside these curvy braces, I can create the format that I want the number to appear in. So to tell it I want to create a number format with a certain number of hundreds and tens and ones places, and then a certain number of decimals, I do a colon. I hope I'm getting all this right. We'll see. A colon to say that it's going to be a number format, and then none of these points per game were more than 99 points per game margin. That wasn't a thing. So I know I'm only going to need 2 at most numbers in the tens and the one spot. So I need 2 of those. And then dot, let's just say 2 decimals. So I could do 2.3 would give me a number up to 99.999 or 00.000, whichever. So hopefully, let's see if this works. I probably have some error. Yeah, I have some error. Let's see. I have to tell it that it's a floating point number. So I put an F in there. And I do something different. Print. Let's see. What does the difference? Unsupported format string passed to a list. Oh, let's see. Do I have to? Because there's a weird thing here because this points per game is actually lots of things, right? It's 130 point margins, and I'm got one here. So maybe that's a problem. Let's try this on the one that does the max. We'll leave this points per game alone right now. I have to think about how that actually works. I'm sure there's some way to do it, but the problem is I have a thing to print one thing, and it's trying to shove 130 things into that thing, and it's not knowing what to do, and I don't know how to fix it right now. So we'll do it. This print max point per game, that's just one, so we'll do that one. Same thing though. Let's do quotations, this, in quotations, dot, format, and then we want to print this stuff. Got to make sure I got enough, whoops, parentheses in there, and let's do colon 2 dot, not comma, 2f. See if that works. I may have to look up how you format this stuff because it looked like it gave me an error. Oh no, it did it. Look, 31.2. In fact, let's get rid of some of it because it's cluttering up everything. Let's comment out that and comment out that so that we only have the thing. There it is, 31.2, and we can change that. So if we wanted, maybe some team did score 100 points more every time, then we'll get, now it won't do the leading zero, it'll do the trailing zeros though. I think I can force it to do leading zeros. I don't remember how I'll do that though. I have to look that up. Oh, well, you copy this exactly. And at that point, it is sensitive to case, spelling. The curly brackets do need to be in quotes. I don't think if they're not in quotes, I don't think it works. Yeah, it doesn't like it if it's not in quotes. So the curvy braces have to be in quotes. The quotes are only around the curvy braces though. And then there's a dot to say that you're going to choose this little parameter format. Yeah, the dot is probably the one that's not obvious. It's not a dot, it's a comma. Also, I mean, it's not a comma, it's a dot. This one right here, this part. No. Oh, this is not a function. This is a variable. So it gets created. Where does it get created? Oh, well, no, it actually is a function. So PPG is the variable that contains, or the list that contains all of the point margins per game, and max is the one that's the largest in that list. So it really is a function. We could also do, let's see who was the worst. Print, well, actually, let's just copy this whole line and do the min one. So this will give us who are, I don't like the 3 trailing zeros, I only want 2. All right, see what our worst one was. -28. So, and you don't really like how those are not lined up. You can go in here and inside the quotation marks, it looks like I need to move over a space. I can put a space in the quotation marks and it will line them up. So, I mean, I kind of hard coded that in because I knew there's a -1 on the negative sign, but so it's not the best way to do it, but it does work. Yep. Oh, all right. So we have the team name, right? We have the team name right here. We just need to know what team goes with this max points per game, and that's what this little routine does. So this max index equals I. Max index is the index of the team with the maximum points per game. So did we print that out? Yeah, well, we didn't, but it's right here. We can uncomment that. Print Oh, okay. So now we have to do something different though. So print CF. We don't have a CF. Go back up to the top. Let's see. Import. There we go. Import custom function. So this is the same custom functions as last time that did the temperature conversion. Also in there is a custom function that converts a CSV file, which we have right there in the green, to a list. So it's already written for us, but we need to actually use it. So now we have something that is CF. You do have to have that custom functions file in the same folder because we didn't tell it to go look in some other place. So we have that, and now this function right here can work, or this print statement can work because it wants to go through that custom function, use the max index idea of, in this case, the max index is 0 because the best team, or the best points per margin, and I guess the best team was Clemson. So it will take their index, which is 0 because they're the first one in the list, and run it through CF. So let's run this. And so all this does is it gives us 0. It doesn't give us the team name. So if we want to know the team name, we can print, let's see, we'll just do oh wait, we need quotation marks. Oh, we can even make this better. The team with the best points per game, and I want to say margin because it's not just points per game. Margin was, and then we can say we're going to put a name in here. We don't know which one. It could be any of the 130. In quotes dot format to format what we're going to put in there, and we're going to put in team, or at least in my, you may have named it different, but I named the list that holds all my team names as team. So I'm going to put team, and I want to put a specific team. I want to put the team that has max index in it, or not in it, but at that position. And notice the team brackets, not parentheses. So I've got square brackets to say that I want the team in the max index position. Max index is currently assigned the value of 0, so I want team in the 0 position, the top line. Hopefully this works. No. All right, let's see. What did I do wrong? Did I leave out a parenthesis? All right. This editor does help you make sure you line up all your parentheses, which I think I've got all of them now. There we go. The team with the best points per game margin was Clemson. I left a parenthesis off the end. There actually needs to be 2 closing parentheses at the end of this. One to close the very first one way over here by the print statement. So everything that you want printed has to be in parentheses, and then some of it's in quotes and some of it's in the format. Oh, all right. So if we did this, I mean, we got to figure out who the worst was. So we don't have a min index, right? But we have this thing that creates a max index. So why don't we just go through? Well, we could probably edit this one, but let's just copy this one and recreate it as minimum. So we need that, and we need that. So I copied from line 50 down to I equals I plus 1 down here. Probably didn't need to do it that way. There are often much better ways to do it than what I decided to do, but that's what we did. So this one resets our index I number to 0. We're doing minimum value. We're going to do minimum index. We can leave this alone, V in points per game, if V is less than the minimum value that we currently have. Now, I did set minimum value to 0. It is possible there were no teams that had negative points per game, so we could change that to some other starting point. But I know in this data set that there are teams with negative points per game. So min value equals the smaller of the current value and the one it just looked at. And then the min index is going to be associated with that. And then we're going to increment our variable. So you don't have to, I would encourage you later on sometime to kind of work through what this is doing, because I'm just kind of talking through it, but you need to. Yeah, so this one is the one that actually goes to the next index number. we're moving through the list using this line 82 for every V in points per game. So every value in points per game, the V doesn't actually mean value. It's just a variable, but that's what I'm calling it. So now we should have a min index. So we should be able to basically copy this line and paste it right down here. And the team with the worst points per game margin, and now we're not lined up again. I'm going to see if that'll line. Oh no, but it does. It's going to have a negative, so I think that actually might. No, there, we'll do that, and we'll do min index instead of max. All right. Oh, it was Connecticut. Oh, this is his name, so I don't have to. And I mean, we have them up here, right? We have the numbers up here, but let's do it different. Let's make it fancy. So let's put the team with the best points per game margin was blank, Clemson, at blah blah. Well, let's just do it. I'm going to run out of room on my screen. Points per game. So now I have two of these little curvy braces. This one, the second one, is a number, and I want to format it so that it's a 2.2 floating point number. So that's two positions to the left of the decimal point, two positions to the right of the decimal point, and it's floating, so it has a decimal point. And then in this bracket, I'm going to format team max index, comma, whatever I put after this comma will show up in the second bracket, and that is my max of points per game. And then over here, we'll do at colon 2.2f points per game, and we'll say that here we want whatever the minimum points per game ended up being. All right, so now we should get team with the best points per game margin was Clemson at 31.2 points per game. Oh, why did I put this team? B team. You just now noticed that. The team with the worst was Connecticut at negative 28.2 points per game. That was an unhappy season, I assume. Let's put a period at the end of our sentence. There we go. And we're still printing that max index. We don't need that. Let's comment that out. There we go. And we could clear the screen and we could do all kind of stuff. So you can start to see how, this formatting is useful. It's not obvious how you mix in variables with the text you want to say, because this you probably haven't done, unless you've written stuff in Python before, you probably haven't done this process exactly. So this is how it does work, and you do have to be careful because it didn't work this way in the little bit older version of Python. It was a little bit different. Same concept, but the stuff you put in there was different. So that's kind of useful. So we've created list. We made a new one. We made the team. We made it empty. We put data in it over here. We just appended to the end of the list all the team names, all the things in position one. If we wanted to do conference equals, oops, not curly brackets, square brackets, conference dot add to the end of that one. I don't know why I have two sets of parentheses around that. I don't need that. C conference is in the second position, I think. And oops, now we would have, it's not going to change our output, but we'd have all the conferences associated with each of these. So we could go in. I mean, you could go on for days. The best team margin was Clemson in the blah blah, and scroll over in the conference. We'll just use that same max index variable since it would also work. Get it all in there, maybe. Let's see. In the ACC Atlantic side of the ACC at 31, and then we can do same thing here in the placeholder. We're going to fill in the placeholder with their conference. MEEN index though. Oops. Connecticut in the American East at, and we got some formatting like it wraps around the screen, but hopefully I can just make it bigger. There we go. We don't really need that assistant. We can just close him out. And so, I mean, you can make it pretty sophisticated, and then you could load up the 2017 data, and nothing would change. The only thing that could go wrong, I can think of, is that there could be a highly unlikely, but there could be a year where no team had a negative points per game margin, and we started our minimum value with zero. Well, zero. And so it could be that it ended up that there was no team with a negative number to get replaced with our default value of zero. You could fix that with just starting your minimum value somewhere else. Or you could have some kind of error trap that says that if none of them were negative, then you have to go through a different routine or whatever. But so it is much better to, when you code something like this, try to think of all the reasons what would break your code and try to eliminate them. But sometimes it's okay to make assumptions where you know certain things to be true. Like, I'm pretty certain that no football team in the current version of football is going to have a points per game margin greater than 100. So I can be pretty sure that I can get away with just two positions to the left of the decimal point when I'm doing any of those things. Although it doesn't hurt to put, we put 3 in there once, it was fine. So you can make some assumptions, but it's generally best to code all the contingencies you can think of, because you might come back later with this same code, 2 years later, put a different set of data in it, and it works differently. So you don't want to accidentally mess yourself up by making an assumption today and then not remembering it years from now. Let's see, what other kind of things? So this stuff would get you through. That would basically get you through a lot of this output. Here they've got, they're not really using the, well, you don't have to write this. This is written for you. This is a different way to create an output string. Basically, they have, where we use the format tag to put data into wherever spot we wanted it in our message. They're actually like building a message by adding it together. So adding little pieces of it together. So that's what all this is. This line, I guess that's 10 and 11. Lines 10 and 11 are creating the output string for this piece of code by hacking it together one word at a time, basically, from this list of units and the output of your temperature conversion, pressure conversion. What we just did would be a lot more like this number 2 right here. Not sure why I did that. There we go. So you go create a CSV file from the where's the weather underground. It says see here, but that doesn't. It's not a link for me. You might have to actually go to it. Create a CSV just like we did. Make sure it doesn't have the extra data in it. Depending on if it has header information or if you just eliminate that yourself, you may or may not have to pop off those headers, which is these lines in this piece of code. I just didn't save them in the first place, but if they were in there, then you could pop off any number of lines to get down to the actual data. And then basically do the same thing, except here they're plotting it versus printing a string of commands. And then this one is very similar, except it's plotting instead of printing. And you have 6 or 7 plotting examples from last class. I think that's plenty of talking about Python for now. And we should still be on track for everything. Next week, we will bring your kits, your raw kits to class, and I'll hopefully I'll remember to get some kind of camera set up so that we can watch some soldering techniques. Some of you, I mean, you've all soldered something in 120 something, 121, 122, but we'll go through this one. There's a lot of little pieces of solder that need to be done that if they're not done well, then it will be hard to track down what's going on in your errors. So we'll try to get the SD cards soldered up next time. So bring them, assuming you have them. Don't try to bring a soldering iron or anything. There is a little lab next door. Remember, it has the code on the Moodle page 2842, I think. Pound is, you have to hit the pound symbol after it. And there's 5 or 6 soldering irons in there. And then there's downstairs, there's soldering irons in some of the prototyping, actually in the printing room has soldering irons set up. And you'll have opportunity to do that. I'll just show you what I would do to solder mine up. All right.